Hi, everybody, and welcome. Hank Preston here, along with David Bombal, in our continuing series on network programmability, DevNet, SDN topics, kind of the whole shebang that's there. And today's session, we have a special guest joining us, Jason Gooley, Technical Solutions Architect with Cisco and expert in all things DNA, DNA Center, SD-WAN, all of those pieces. And I asked Jason to join David and I to have a bit of a deeper discussion on DNA and DNA Center and kind of show us some highlights, talk about where the technology makes sense, how it's going to make all of our lives easier as far as kind of doing the networking thing is. And so thanks, Jason, for joining. And David and I are going to hammer you with a bunch of questions and looking forward to seeing what you got for us.
Sounds good.
So Jason, really looking forward to this. Last week, Hank told me a bit about DNA and sort of the positioning of DNA. So Hank, I don't know if you want to just mention that briefly, but I'm looking forward to a deeper discussion.
Yeah, that's a great point. So when we did our video last week, for those that have seen it or maybe the ones that haven't, what we talked about and I mentioned is that DNA and DNA Center are very much focused on that enterprise networking use case. So in the campus, in the WAN, kind of controlling all of those pieces that are there, rather than something like ACI from Cisco that fits into the data center solution. And so teeing up off of that, can you elaborate a little bit? Where does DNA and DNA Center fit into, and why is it being positioned as kind of the next generation networking platform from Cisco for the enterprise and wireless and WAN and all of these pieces?
So that's a great question. First off, I want to thank you both for having me today. I really do appreciate it. So that's a long question, but I'm going to try and answer it as succinctly as possible, right? So the concept of DNA Center is mostly for the networking engineers. It's designed to basically make your lives a lot easier, our lives a lot easier, right? Yeah, traditionally, when you're configuring something, it's always been manual. You're having to go from box to box, and then next thing you know, when you're troubleshooting, you're chasing the chain or looking at all these different issues as you go down through all the different devices. And we got to come up with a different way to do that and make it a little bit easier and ultimately a lot faster. And that's where DNA kind of fits in. It's designed to make it easier for the network engineers to get done what they need to get done so they can focus on the more important things in their life, right? When you start thinking about configuration, oftentimes, putting programmability aside, most of the customers and engineers have to do this on a very manual basis. And DNA Center gives you the ability to automate a lot of those mundane changes just to make it simpler so you can, again, free up some more time to do the more important things.
So I think that makes sense, and I like the idea of making it simpler and going through, but I think that's one of those things that's easier to show than to just explain and talk about. Can you give us a real world example? And maybe, I know you've got the system set up that you can kind of show us how DNA Center makes a routine activity simpler for an engineer, let's start with configuration, if you've got something kind of lined up for that.
Sure. So for example, one of the things that customers go through, and I came from the customer side, I've been a customer for most of my life, and one of the things that they go through is they have to stage equipment for it to go out to other locations. So for example, the typical process would be we order some equipment, from a partner, it gets shipped, you unbox it, you plug in your crossover cable, you plug in your console cable, you have to go through all this configuration to make sure that it has whatever config you need, upgrading the code, doing all these things, right? And then after it's all said and done, unfortunately, you have to box it back up. And usually the person who is in charge of doing that is the one or two people who run the whole network, who then have to get on a plane and then fly out and go and install it too. So just that entire operational chain of stuff that has to get done could be made so much simpler. And I'll show you an example of that, right? So this is DNA Center that we're looking at. It is an appliance that has software that runs on top of it that allows you to manage and monitor your entire network, right? From a campus perspective, like you mentioned. So if you go to this provision thing that we have here, down in the bottom left, if we click on that, this is essentially where everything changes for us as network engineers. If you start off thinking that, again, I mentioned that entire operational flow of what you got to do. Well, now imagine, if you will, we order the equipment directly from the partner. It now gets shipped directly to the end location. Somebody plugs it in who doesn't have to be a CCIE or an expert in anything. They plug it in. It'll automatically phone home back to DNA Center, download the proper version of config, download the proper software image, and it instantiates itself. Boom. You just took that entire flow down to just a couple steps.
So can we talk a bit about that one that's there? So the concept of taking a new device out of the box, plugging it in, and having it phone home, that seems like a little bit of magic. Like how does that work? What what's some of the pieces that allow these equipments to make themselves back?
So that's a great question. And if you think about it, typically there's things like power on, power on self provisioning and all these other weird things you've heard, POPE and all these other things. But think of it much simpler than that. Imagine that you have a DNS entry that is registered in your environment to point to DNA center. And it's a key that automatically gets checked during the boot from these routers, switches, or access points for that matter. So it'll automatically look for this key and then do it via either DNS, or it can do it via like a program that we can actually run on our laptop and just click a couple things and it'll automatically check in and download all the configuration. You can even do it from a smart device.
So if I understood that right, so there's different options for it, but one of the simplest ways is when you plug your first switch in, they're set up to go out and request via DHCP some basic just connectivity information. And one of the things that DHCP can send the switch is a DNS server. And so as a network administrator, you just put an entry in your DNS for something like DNA center dot whatever your company's domain is .com. That's as simple as that, huh?
It's good.
Excellent.
It's as simple as that. And once you do that, it can go back in and check in and do some of the things I'm going to show you.
Perfect. And David, did you have a follow-up question on that?
Yeah, so Jason, I just wanted to be the cynical network engineer in the call. So I remember years ago, showing my age, Cisco had SLOP, which was the serial thing where you connected one router to another router on a serial link, and then it would use a protocol to get an IP address and then somehow magically get a configuration from a TFTP server. So it's kind of like we've been promised this for a really long time. But cynical network engineer, sorry to play the hardball here. But this sounds like kind of the same idea. So just stepping back, me as a network guy, when you said that, first alarm bell was, okay, so does Cisco ship these devices, I'm assuming routers and switches, newer devices, with some kind of something magical that it automatically looks for that DNS entry? How is it something in the iOS or something that it knows that, okay, look for this DNS entry and then connect to something?
Right. So it is actually part of the iOS. So one of the things that has changed with the advent of iOS XE is we've had the ability to add different pieces and components to the actual software itself. And if you think back, if you remember things like autoconfig, where it would automatically download like the router RTR configuration file, and in that it would automatically look for something, it's that same kind of concept. It's leveraging that. Or again, one of the other things that I mentioned is you can even use an app on your phone or whatnot, or a USB stick to boot it, to have it point to whatever thing you want it to point to, whether it's DNS or a specific IP address within your environment as well. So there's a slew of different options, but yes, it does go back to the idea of being able to make things happen automatically with the least amount of manual intervention possible.
Yeah, so basically it boots up, gets an IP address, as Hank was saying, just for my understanding again. Assuming we're using the DNS example, it queries this, it gets the DNS server information and then uses that some special entry to get the configuration from a central device, which would be a DNA or something. Is that right?
Correct. So you think of it, so we call it plug and play, and it was similar but more advanced than the traditional prime plug and play that we had. So now with this plug and play capability, these devices will check into DNA Center, and then this is where you can actually have stuff pre-provisioned where it can download and pick whatever software or images that you want it to have and then instantiate itself.
Now, I must admit, I give you a lot of respect because you mentioned router.cfg, and I remember, all that stuff. So that's really cool to hear that, this is kind of an evolution of that. So let me keep quiet and show us how it works if you can, Jason, or Hank, ask questions. Sorry to jump on this.
No, it's a perfect question. So, for example, we mentioned that we have the ability to pre-provision things. So let's talk about that just a little bit. We can see there's devices here in DNA Center. In this case, it's an access switch. It's in San Jose. It has an IP address, serial number. This is all this different information that you get. You can actually click on a device and manually provision them by clicking Actions and then Provision. But what I wanted to talk through is that we mentioned briefly being able to automatically download this version of software. But how do we know what version of software we want and what configuration for that matter? There's something that we have, it's called Software Image Management, or we want to acronym it, so we call it SWIM, right? So we have something called SWIM. In SWIM, it gives us the capability of being able to pick a version of software. We can mark it as golden. And essentially what that means is, for either the type of platform it is or the device role, whether it's a access switch, distribution switch, or whatnot, you can specify a version of software that you want to automatically be used for those different platforms. So think about standardization from a network engineer's perspective. Most of the time that they spend either after hours over this long course for a rollout to upgrade switches and devices because they have a new version of software that came out. And they have to make this long project that takes months, if not sometimes years, depending on the size of the company, to upgrade all these different devices just to get to a point where it's like, oh man, now I got a new software I got to upgrade and start all over again. So this takes a lot of that away. I'll show you what I mean by that. If you say provision, essentially what that gives us is the ability to pick the location that that device is physically sitting in, and then assign it to different roles or whatnot in that location. So if we click next, we'll skip these couple steps just to kind of show you all these different settings and things like that are what automatically get pushed down to those devices. And you can preset all this different stuff up by using what we call the design tab. And I'll cover that in a moment because I wanted to start with provisioning first. But essentially, we pre-design what we want these network locations to look like. So if you think about that, if you think about things like rolling out 20 to 50 sites, merging with another company where we have to make sure that all these sites are already pre-set up so when they connect, they automatically have the settings and stuff they need. We can pre-build all of this and define it prior to ever having any equipment bought or shipped from a partner or Cisco. So by doing that, now we have these settings already in. So when you're either flying out on site yourself and plugging it in manually or having it shipped directly from the partner and having somebody on site just plug it in, it will log in based on what we talked about and download all these settings and build itself up. So another thing that we mentioned was that we want to talk about how to upgrade these images and this whole golden image concept in SWIM or software image management. If we come down here and we just select a device and click Update iOS image, or Update OS image for that matter. So once we pick the version of software that we want, we can actually then just click the button and then click Deploy on that image, and it will upgrade that device to whatever version of software we want it to go to, just by clicking Update. Obviously, you select one of these devices and you click Update, and it pushes it to that version of software.
So a question on that one. So I've done plenty of network OS upgrades in my day, and they're always these very large projects, as you mentioned. We do a lot of planning. We know the steps that are involved. They often have to happen after hours, maybe a trip out there, because of the impact that goes through. I'm a little bit cautious. I'll play the cynical network engineer for a little bit here. Clicking a box that just says upgrade in a GUI and then going off to lunch, like, what's DNA Center going to do when it goes through? Is it making sure that the OSs get copied successfully? Is there any kind of rollback process if something doesn't boot appropriately? Like I got a bit of a comfort zone issue with just clicking a button and having it just go do its thing.
Yes, so that's a great point. One of the things that it does is, if you can see, there's this thing that says upgrade readiness, and when there's devices that are requiring upgrade, it'll say right here, where it says OS image, it'll say out of date. And if it says out of date, that gives you the ability to know just by looking at it that it needs to be upgraded to whatever version. Meaning that if you picked a golden version for whatever type of platform or device role and that device does not have that golden version, it'll tell you that it's out of date. But the cool thing that this does that, again, we wish we had this for 20 years, was the ability to say, well, okay, well, not only does it need this version of software, it can tell you if it's, it does these pre-checks and post-checks to find out if the device is even ready to support that software. How many times have you been in the trenches getting ready to do an upgrade, and then you found out you didn't have enough flash, or you didn't have enough memory in your router to be able to copy these things over, and then you're copying stuff after hours, and you're up at 2 o'clock in the morning, and it doesn't work. So then you have to delete some of the iOS, like the active iOS. You have to delete it just so you can replace it with this other one to make room. And obviously, if something goes wrong at that point in time, you're toast, right? But this will all automatically do a pre-check, and it just gives you green check boxes, and it'll tell you, it has the right amount of memory, it has a perfect amount of flash, and then what it'll do is it'll, just like we would do manually, it copies that software file down to the router or device, and then it sits. We would normally have to then go through, change the boot statements, then throw a reload at it, right? This will do all of that, and it's basically a circular wheel that checks everything constantly. So it makes sure that it has all the pre-checks. make sure that it's pushed down there automatically. And then even, which is I think really cool as well, we've put in built-in change control. So we can tie in the capability of saying, is it even approved to have this software image upgraded at this point in time? So we can go through all that prior to even doing anything and say, it'll do the pre-checks. Yes, it's ready. Is this approved change? Yes or no? Then it'll go through, copy it down, automatically change the boot statements and stuff like that. Reboot, do a post check, make sure that it came up on a proper version, and there you go.
Is it possible to let it do all of that, but not actually do the reboot? So you manually verify it. So you get it to do all that like mundane stuff, and then right at the end say, okay, now I'm going to do a final check myself and then reboot the router.
I'm pretty sure there's a setting, and I'll have to double check on that, but I'm pretty sure, yes, I believe there is a setting where you can uncheck the fact that you want it to reboot. So basically, it stops after it copies everything over. I think you can even have it just copy it over and not even change the boot statement, right? Because sometimes you don't want to do that. You just want to pre-push and deploy the software out everywhere and then pick a time that you want to switch the boot statements and reboot. The other thing that I mentioned, or that I didn't mention, is that you can schedule this. So if you say you don't want to do that, or you just want to have it do everything at once, but you want to do it when somebody else is on call, you can you can schedule that, for a different time or date and have it do it, or during a maintenance window or a weekend for that matter.
Yeah, where do I buy this, Jason? When you're on call, come on.
Yeah, see, exactly.
That's a great feature. So one last question here on the provision, because I'm interested to jump into the design tab and understand what it looks like to actually build out the policies that are there. I see a bunch of different devices in here. What are the devices that are supported by DNA Center? Like, what can I put in? Hardware platforms? Are there software versions that are required for me to use? Like, when can I start to use DNA Center in my network?
So yes, yes, and yes. There are specific versions of hardware that are supported for this, right? Anything that is currently shipping today is supported from an enterprise networking perspective. So we're talking routers and switches and wireless devices, wireless LAN controllers, things like that. However, there are certain versions of software that you kind of need to be on to make sure that DNA Center can take advantage of it. Most of the time, I want to say it was starting off with like, it might be 16.6.1. Don't quote me on that, but I'll have to go back and double check. But there is a specific level you need to be on in order for it to be seen by DNA Center. And then what we're doing is we're actually opening this up to more third-party and different types of devices within Cisco. So it won't be long before you start seeing things like some Nexus devices in here, just from a access perspective.
Mm-hmm. Okay, perfect. So let's switch over from provision to design. When we build networks today, or when I would build networks in the past, my design process, my template process would usually start out in Notepad++, and I would start kind of building out my CLI templates. I'm good at that, right? We're all been good at that. We've all got piles of those, but clearly that there's some challenges with those types of models for consistency and rolling them out and other pieces. So what is designing a template? What does designing the network look like when you're using DNA Center?
So imagine, instead of having to go through all the processes of, typically doing what you mentioned, or writing and drawing out all the topology diagrams and all the logical design that you would normally do as a network engineer, you can now do via this GUI. So what do I mean by that? So for example, let's pick on, just for North Carolina or North America, then we'll go to USA, and then we'll pick on California, because I think we took Raleigh out of here. So we have a San Jose site. For instance, we pick on this site, we can see that it gives us a logical view of where this device or this site will actually physically be located in the world, right? In this case, we're picking on San Jose. Under San Jose, you can have specific buildings. From the building perspective, you can have floors. So maybe San Jose has a building 1 and a floor 1 for that matter. If you think back to how we used to do stuff in Prime with wireless, we would have floor maps that would have all of our devices on it. It would show wireless capabilities and things of that nature. With design, again, I mentioned we can pre-build all this stuff out before ever even having any equipment on site. So we can build out the capabilities from wireless, all the different IP address settings and pools that are required for sites and things like that, without having to manually go through all these different steps that we would used to have to go through. So in this particular case, there's a wireless layout. You have the ability to put a bunch of different network settings in, again, prior to ever even having anything out there. So when we talked earlier, and I showed the provisioning step, and I was getting ready to click deploy, it showed all these different settings that were automatically getting pushed down to those devices. All those settings you build out here within design. So whether it's AAA, the ICE servers, DNS, DHCP, syslog, all of that good stuff that you normally build out, you just build it with a click and drag within design, and those are the settings that get deployed to those sites. If you come over here to something like IP address pools, for example, before, I know a lot, even myself and my old company and a lot of customers, they manage IP addresses through spreadsheets, right? You might have the DHCP scopes in the DHCP server, but then to keep track of what has what, they go through and they have a lot of spreadsheets to keep track of the routers and the switches and all these other devices, because most of the time they're static, right? They statically assign these hard devices and then they DHCP the rest for all the hosts and things of that nature. With DNA Center, you don't have to worry about that because you create these pools. In addition, and I might be going ahead a little bit, it has the ability to connect through what we call IP address management platforms using things like APIs and stuff like that to keep track and use all the context that the customers use so they know what all these IP addresses even mean.
So can I jump in with cynical network engineer again?
Sure.
Sorry, Jason, we're giving you a hard time today.
It's okay.
It's just trying to get my head around how it all works. So stepping back, Hank, I think last week you mentioned the southbound protocols. In other words, the protocols from this DNA center to the network devices would be CLI, netconf. Is it SNMP as well?
So I think it depends on the devices that are there. We're going to use different protocols that are in place that are going through. But Jason, specifically, do you want to comment on like how DNA Center picks or which protocols are used for which different types of aspects?
I'm glad you said that. You see this thing here? This is device credentials. I'm going to click back over here and click on that and show you what I'm talking about.
Yeah, Jason, I'm going to build into a bigger question after this. So I'm glad that you're showing this here because it looks like I see you got SNMP there, yeah?
Sure. So DNA Center, imagine it's a platform that kind of monitors and manages all your devices. So it can be done in multiple different ways, either via CLI, SNMP, HTTP, HTTPS, things like that. So it can use all these different protocols to log into different devices and gain and gather information. It also could use APIs to talk down to devices as well, whether they're routers, switches, wireless access points, things of that nature as well. So there's multiple ways for DNA Center to integrate and interact with the devices that are at the southbound layer.
Yeah, so being the cynical guy that I am, this looks like a management platform. From what you've shown me, and I'm assuming there's more than it can do a lot more, but thus far it looks like management type stuff, like central management of devices, deploying of configurations, operating systems. So how is this different to, say, and I won't mention names, say other management platforms that you have out there?
So another good question, right? So it is a management platform as well, but wait, there's more. So not only does it manage, and this is one of the things that the reason it looks like this and the reason that we have built this out is because we've taken all the feedback from our customers. Customers have been saying, look, I want one place to go. I want a GUI that will not only manage my devices, I want a GUI that'll monitor it from a troubleshooting and verification perspective. I also want it to be the same platform that we use for automation to instantiate all the changes and configure the devices as well. And we finally got to a point where we have that platform. I mean, if you think about it in the past, we had Prime, we had all these other things, Cisco works when it worked.
Yeah, I'm glad you said that. I was thinking that the whole time, but I didn't want to say that.
You might have to edit that part out. No, but the idea is that we needed to get to a place where we had one platform that could do everything. If you think about, you mentioned software-defined networking a little bit earlier, Hank, and what that means. Essentially, if you're taking that level up and you have that controller, right, that sits above and on top of your network, and it can look at and manage all the different devices you have in your environment. This is the whole concept of this. Now, not only does this thing do all the management, because it is also that controller, it's what talks down to all the other devices, and it's also what can be talked to via all the other APIs from other tools such as ServiceNow or IP address management stuff like Infoblox, because it is not only a management platform, but it's also the software-defined controller for your environment. similar to ACI has the APIC in the data center.
Yeah, I just want to make an important point. I looked at a presentation online, and the guy that presented, I can't remember his name now, from Cisco, emphasized that this isn't OpenFlow. So this thing doesn't support OpenFlow and making the devices dumb. The devices still have their local intelligence. Is that right?
That is 100% correct.
Yeah, so we've got SNMP, we've got HTTP, CLI. Sorry, there's a bit of delay on the link. So it's SNMP, netconf, HTTP, CLI kind of stuff. Is that right? There's no OpenFlow.
Right, correct.
Great. Jason, thanks. I'm a lot more happy about that as the cynical network engineer, because I was concerned, looking at this, it kind of looks just like any other management platform. And it's good to know that it does more. Yeah,
it does a lot more. And one of the things that I should mention is, I mentioned being able to build out the wireless settings for remote sites. One of the things that we did was we talked to a lot of our customers, and we talked to a lot of people internal to Cisco and said, what if I want to create a new wireless network? How would I normally go about doing that? And I have to move your video here a little bit so I can click it. Typically in the past, you have to go to the wireless LAN controller, right? I mean, you have to go to the controller, and God forbid you were running autonomous APs, where you didn't have a controller at the time. You had to go to every single access point to create all these SSIDs and make sure all those settings matched across all of them in your environment. Otherwise, you're going to have wireless problems when you're going from one device to another. So in this, we literally took it and we made it so it's as simple as this. What is the SSID I want? Maybe we want to call it Hank. Do I want voice or data? Do I want, data only? And then we have this capability called Fastlane. So I won't dive too deep into it, but we partnered up with Apple. So we have an Apple partnership. And what that gives us is the ability to utilize things on these iOS devices. There's something called Fastlane that is built directly in the Cisco wireless products that allows any Apple device running Apple iOS the ability to have precedence from a quality of service perspective over the wireless. So you can streamline and essentially make apps running on your iPhone more efficient. So think of healthcare and things like that and all these other different use cases, but you have the ability to streamline and fast lane essentially the wireless stuff from an Apple perspective. Then we just come down to the options. Do we want 2.4 gigahertz and 5? Do we want 5 gigahertz only? Do you want to do any kind of advanced security options? Maybe, maybe not. You click next. What profile do I want to assign it to, and finish, right? By doing this, you're essentially took out all those steps that you have to configure when you're building out a wireless network, and you have it within like 5 clicks.
So why is this better than Prime or other network management applications? Sorry to put you on the spot.
No. And if you think about it, Prime was Prime, right? And then after Prime, you would have to then go through and do other things like configure different devices and things like that. Prime didn't give us everything that we needed from an automation perspective. It wasn't a software-defined controller. It was literally just a management platform that kind of sat there. So it didn't have the capabilities that this does to be able to do things like automatically push stuff down via API down to these devices. That is where the power of this platform comes in, because it's one platform. So the one platform can not only do some of the stuff that Prime did, it can configure all the wireless stuff, it can automate all the changes and tasks, it can do plug and play, it can configure things like IP address pools and things like that without having to manually go through and do it like you would have done in the past. As well as it does things like assurance, where it gives you the capability of monitoring the network and getting guided remediation steps from troubleshooting and all these other cool things that we'll probably cover here in a minute. And again, customers said one platform, right? And that was why I'm not saying Prime's dead or by any means. A lot of customers still use it and we still support it. It's just that we needed to do something and consolidate everything into one place. Otherwise, it wasn't making the engineers' jobs any simpler.
Yes, I've got 2 questions for you. Sorry, I don't want to hog this. We might have to have more calls, Jason. I'm just playing, cynical network engineer, like the why. Why do I care? So if I'm a network engineer today, if I was going to recommend a product to my management team, like the boss, I wanted to recommend a management / next generation application for management, deploying automation, stuff like that in an enterprise, this is the product I should recommend, not Prime and other stuff. Is that right?
That would be my opinion. And yes, I agree with that. And the reason being is mostly this tab right here. From a network engineering perspective, most of your time is either configuring mundane tasks like I need to set the VLAN on this port because somebody plugged a phone into it, or I have to troubleshoot. And troubleshooting traditionally takes a tremendous amount of time. And if you think about that, the typical path that you would use to troubleshoot is somebody comes in and says you have a wireless issue or some sort of issue, or you get a ticket and it usually sits in the queue for about a week or so. Then you get this ticket and it was, somebody last Tuesday at 3 p.m. couldn't get on the wireless network and we couldn't figure out exactly why. So how do you troubleshoot that typically? I mean, typically you jump into, to the wireless network and you start looking at things, and then you go back to the switches to try to figure out what happened, and you're jumping from device to device to device, chasing this chain, so to speak. And it's almost impossible to find the issue because it happened last Tuesday at 3 o'clock in the afternoon. This is where assurance comes in, right? I mean, if I said there was one thing that if I was a network engineer and I had to preach it to my management that I needed, it would be assurance. And I'm not taking away from the automation. I'm not taking away from the being able to do the design and plug and play, which saves a bunch of time and money and all that stuff we mentioned. But the troubleshooting is traditionally the hardest part, right? Because usually you have your management standing over your shoulder. Why is something not working? And oftentimes you have to go through all this stuff to prove that it's not the network, right? It's mean time to innocence, so to speak. I need to prove that it's the application or something like that. That's where assurance comes in.
Yeah, I'm glad you mentioned that because, I mean, I'm looking at this from my sort of selfish point of view as a network engineer. So what does this give me? And what you've just said there is it saves me a lot of stress. Because
a lot of stress. Time and stress, right?
Yeah.
So what does...
So this is assurance. Go ahead.
I think you're going to go into it, but you've kind of set us up that troubleshooting is easier with assurance. So what does the troubleshooting flow look like by using DNA Center and assurance?